Hello, I'm Pat O'Loughlin, President and CEO of Buckeye Power. I'm pleased that you're interested in finding out more about how Ohio's electric cooperatives produce the power you use. Not only because we're proud of what we've built here at the Cardinal station, but because education and communication are two of the 7 basic principles that form the foundation of how cooperatives do business. Since ground was broken in 1963, the Cardinal station has grown and adapted to continue to meet the needs of Ohio's cooperative members and will continue to meet those needs for many years into the future. We hope you'll all enjoy this virtual tour of our power plant, and when it's over, you'll have a better understanding of just how much is involved in making sure that affordable, reliable, and clean electricity is there when you need it.
In the early 20th century, cities were ablaze with all the modern excitement electricity brought with it, while the countryside was dark. The advent of the Rural Electrification Administration ushered in a new era where neighbors were able to join with neighbors to form not-for-profit electric cooperatives and bring electricity out of the cities and onto the farm. From that day in 1935, when the first REA pole was set in Piqua, Ohio's cooperatives have worked toward the goal of safely providing affordable and reliable power for their members. At first, Ohio's cooperatives purchased electricity from others, but it was clear that to better serve their members, Ohio's cooperatives needed to control their own source of generation. Buckeye Power was formed, and after several years of negotiations, reached an agreement with American Electric Power to build the Cardinal station. First with Unit 2 in 1968, and then with Unit 3 in 1977, Cardinal has been bringing the light and the power to rural Ohio. We flip a switch and the light comes on. We take it for granted that power will be there whenever and wherever we want it. But did you ever stop to think about from where that power comes and how it's produced? Ohio's countryside. It's a nice place to grow up, raise a family, own your own business. One big reason is because rural Ohio is served by consumer-owned electric cooperatives, which offer competitive rates and excellent service while being an involved and vital contributor to the communities. And part of the strength of Ohio's cooperatives is the Cardinal station, their dependable and economical source of electricity. Located about 7 miles south of Steubenville in Brilliant, Ohio, along the Ohio River, the Cardinal station's 3 coal-fired units generate 1,830,000 kilowatts, enough power to serve nearly 1 million homes, farms, and businesses. Buckeye Power Incorporated, a power generating and transmission cooperative owned by the 25 electric distribution co-ops serving Ohio, owns Cardinal Units 2 and 3. Unit 1 is owned by American Electric Power, which operates and maintains the entire station under contract with Buckeye. Coal is burned to produce electricity at Cardinal. To provide enough electricity to meet the needs of an average electric cooperative member, about 1,200 kilowatt hours a month, Cardinal burns about 6 tons of coal a year. Overall, Cardinal Units 2 and 3 consume nearly 4 million tons of coal in an average year. Perhaps the best way to understand what happens at the Cardinal units is to follow the coal as it arrives. Coal is delivered in 3 ways: by truck, by rail car, and by barge. Cardinal's location along the Ohio River is ideal for a number of reasons, one of which is barge transportation. It takes about 12 barges to supply Cardinal's daily needs at peak load, and it takes about an hour to unload one barge using mechanized coal unloaders. Conveyor belts move the coal to the storage piles or into the plant for immediate use. Similar systems are used to move coal from rail cars and the many trucks that supply Cardinal's daily needs. A significant amount of coal used at the Cardinal plant comes from nearby mines and is delivered to the plant by truck. Cardinal's truck unloading facility can handle 3.5 million tons of coal per year. Once the conveyors move coal into the plant, pulverizers reduce it to a fine dust, like talcum powder. This pulverized coal is mixed with air and blows through large pipes to the boiler. Automatic feed systems operated from the main control room determine how much coal is fed into the unit. Each unit has its own control room, which serves as its nerve center, adjusting coal consumption and power production to meet the changing demand for electricity. The boiler is the focal point of each unit. Think of the boiler as a giant kettle of water. The coal is burned to heat water in the boilers into steam. The pressure of that steam turns a turbine, which turns a generator, which produces electricity. Even though the physics of how it works is simple, the technology is not. Instead of a tea kettle, Cardinal uses a 20-story boiler, but its size doesn't mean it's easy for the casual observer to see. It's surrounded by the pipes that move air and coal in, fans that draw air in and out, tubes that move water around the boiler, pipes carrying steam to the turbine, and pollution control equipment. The boiler itself is suspended from the top of the building which houses it, because the temperatures inside can cause it to expand downward by as much as 12 to 18 inches. The pulverized coal and air are blown into the boiler from burner ports on the boiler walls and ignites. Each of these ports is about 3 feet across. A massive fire with temperatures that can reach 2,500 degrees Fahrenheit burns inside the boiler and heats ultra-pure water inside 1-inch tubes to more than 1,000 degrees, causing the water to flash instantly into steam. High-pressure, high-temperature steam from the boiler is directed into the turbine generator through pipes that are wrapped heavily with insulation. Inside those orange housings at left, the turbine is connected by a shaft to the electric generator. As steam hits the turbine blades, the shaft turns the generator's rotor at 3,600 revolutions per minute. Inside the generator, the rotor turns, rotating an electromagnetic field. That produces electrical power at 26,000 volts. That power goes through a transformer and is stepped up to 345,000 volts, then sent out on transmission lines to consumers across the state. It takes a lot of supporting technology to make this steam process work efficiently. The most important thing to understand is that there are 2 separate water circulating systems working simultaneously, but the boiler water and condenser water never actually mix together. Once the boiler steam has given up most of its energy in turning the turbine blades, it passes through a condenser below the turbine floor. The cool water circulating through the condenser lowers the temperatures of the steam, converting it back to water. This pure water then is forced back into the tubes lining the boiler, where the fires inside recharge it into steam. The warmed condenser water is pumped out to the cooling tower, where it cascades down over fill material that breaks the water into fine droplets. Air rushing through the base of the cooling tower naturally cools the droplets, which then collect in the base to be pumped back to the condenser. The hyperbolic shape of Unit 3's 423-foot cooling tower creates a natural draft as more than 300,000 gallons of water per minute circulate, dropping the temperatures of the condenser water by 20 degrees. The small amount of water lost through evaporation out of the top of the cooling tower is replenished from the Ohio River. While the cooling systems handle the heat, special equipment is cleaning the hot air coming out of the boilers. About 14% of the coal that is burned inside the boiler is not consumed. It remains as particles of clay, rock, and minerals known as ash, similar to the ash left when you've built a campfire. About 80% of this non-burnable material is light enough to float out of the boiler along with hot gases. It's called fly ash. Electrostatic precipitators prevent fly ash from being discharged into the atmosphere, using electrically charged plates to attract and catch the ash. All 3 Cardinal units have precipitators, which remove more than 99.5% of the fly ash produced by burning coal. That translates to about 85 tons of ash per hour when all 3 units are running at full load. So what happens to the more than 450,000 tons of fly ash that's collected by the precipitators each year? It's mixed with water and pumped in large pipes up to a collecting pond for disposal. Some of the particles in the fly ash, called cenospheres, have commercial applications and are harvested for use as fill materials in the manufacturing of plastics and space-age ceramics. The other 20% of the ash produced, which falls to the bottom of the boilers, is called bottom ash. It's stored in ponds next to Unit 3 and is sold as an ingredient in road construction material and cinder blocks, or for snow and ice control on highways. Buckeye Power is committed to preserving a healthy environment and spends millions of dollars every year operating and maintaining environmental control equipment at Cardinal.
Cardinal Station takes its role as an environmental steward very seriously. This commitment to a clean environment can be seen through the investment made by AEP and Buckeye Power in state-of-the-art environmental control systems that have made Cardinal one of the cleanest plants of its type in the world. And our involvement in protecting the environment doesn't end there. Several millions of dollars are spent each year just for labor, materials, supplies, and electricity needed to operate and maintain our environmental controls. Cardinal Station also does its part to protect our environment by being a concerned member of a number of groups dedicated to preserving the quality of the Ohio River and the wildlife that calls the river valley its home.
A number of wildlife and habitat observation and preservation projects are ongoing at Cardinal Station. Generations of herons, egrets, and other wild bird species have grown up at the fly ash pond. The newest additions to the wildlife around the Cardinal Station are peregrine falcons. To date, Buckeye Power has invested approximately $1 billion in environmental controls on Units 2 and 3 to help keep Cardinal in compliance with all federal, state, and local environmental regulations, including the Clean Air Act and the Clean Water Act.
The Cardinal plant is now equipped with state-of-the-art environmental control equipment, making it among the cleanest coal-burning power plants in the world. We've invested in selective catalytic reduction systems, flue gas desulfurization systems that scrub out more than 90% of regulated pollutants such as nitrogen oxide, sulfur dioxide, and mercury.
The FGD system also results in a marketable byproduct. Commercial-grade gypsum is derived when sulfur dioxide reacts with calcium carbonate, or crushed limestone. Since the first FGD unit became operational at Cardinal, more than half of the gypsum produced has been sold to a nearby wallboard manufacturer. The excess gypsum is transported and stored in a landfill area near the fly ash pond. The completion of the Unit 3 FGD system in early 2012 culminated years of air quality work at Cardinal. These investments in technology make Cardinal one of the cleanest coal-burning generators of electricity in the world. Ever mindful of doing what is best for its members, as part of the Unit 3 FGD project, Buckeye Power tied in the flue gas dispersal system with the cooling tower, avoiding the cost of building a new stack. This is the first time this type of system has been used in North America and saved millions of dollars for Ohio's cooperative members. For decades, Cardinal provided all the electricity Ohio's co-ops needed. But today, with the growth of Ohio's co-ops, Buckeye Power has secured additional generation to ensure that members continue to have the electricity needed.
Today, Buckeye has a diverse set of generation resources to complement the Cardinal Station's production. Buckeye is part owner of two other large baseload coal-fired generating stations near Gallipolis, Ohio, and Madison, Indiana. Buckeye also owns natural gas peaking plants near Van Wert and Greenville, Ohio, which are used for periods of high electric demand. Over the past decade, Buckeye has also added renewable energy resources, hydro, wind, and biomass to supplement our fossil fuel generation.
Buckeye Power is at the forefront of renewable energy in Ohio. It has agreements to purchase power generated by biodigesters from a poultry farm in Mercer County and a dairy farm in Williams County, along with a methane generation facility at a landfill in Perry County. Together, these projects supply enough electricity to serve more than 3,500 homes. Buckeye Power also has a 30-megawatt share of the Story County wind farm in Iowa. Buckeye has ongoing research projects to test the viability of wind and solar power at different locations across the state, and other renewable sources will be added to Buckeye's power supply as they become available.
People who visited the Cardinal Station always talk about how impressed they are by its sheer size and the complexity of its operation. But what's really impressive is how, more than 5 decades ago, a group of 24 small electric companies, along with help from some important allies like American Electric Power, found a way to unite in a common goal of serving rural people and building the Cardinal Station. The power generated here is a monument to their foresight and to the power of cooperation. Today, our continuing investment in Cardinal demonstrates our commitment to the vision and our values: accountability, integrity, innovation, and commitment to community. as Touchstone Energy Cooperatives. We're already looking years into the future of the Cardinal station. That too is part of our commitment to our electric cooperative member consumers. Because more than 75 years ago, Ohio's electric cooperatives brought the light and the power to folks living out in the country. And we still want to be there building a brighter tomorrow when our grandchildren's grandchildren flip a switch to brighten the countryside. That's the true power of human connections.